In my last video, I showed you some of the workflow automation tools offered by some of the popular vendors that most people are using these days. In this video, we're gonna be focusing on the same kind of tools but offered by cloud providers. Cloud providers are known for the hundreds of available services and offerings, but we're gonna be choosing just a few that fall under the umbrella of business process automation and aim to improve operational efficiency. But this time, we're going to be focusing on some of the specific features of those tools, such as availability of a visual designer, integration options with third-party services, and we'll explore targeted use cases for automation. We'll also examine how much coding is involved, how portable the configuration is, and delve into some technical aspects to understand the solution architecture that's behind it. Additionally, we'll explore the skills required to be comfortable using the tool, and finally, we'll take a look at the pricing model. I've chosen a couple of services per cloud provider that we're going to be checking out. Those are quite similar and yet for a specific use case, which I explain, and I also want to pour some AI sauce into it. Alright, let's talk about GCP application integration first. I want to start here because it's intended to be used for automating business processes, and as such, it's high level enough for us to kick things off. They call this thing Integration Platform as a Service because basically, that is what it does. It simplifies application integration by offering you a visual builder, as well as convenient abstracts such as triggers, connectors, and data transformations, without even mentioning the AI part, which is, to be honest, is everywhere these days. It's actually been actively developed for the last couple of years. They've provided with quite a few new features, mostly related to introducing new connectors, triggers, and tasks that handle various data transformations. Let's review a high-level architecture, because that's going to give you a little bit of an idea how things are interconnected in this picture. Application integration remains a central one, and that's where your logic is going to be. It's also going to consist of some flow control elements, some data transformation logic, and some probably time-related and approval events. Other things are external to this block, such as triggers, that's where the flow is going to be initiated, and some connections. Most connections to Google services, but there are a few available that you can build on top of to connect to third parties, such as REST endpoint, for instance. But now let's have a look at the design in the console, because that's where you'll find all the relevant elements available to build integrations. All of the available triggers are shown in this drop-down menu, which really limits them to just a few. Some of them still in preview mode, because this thing again, being actively developed. Those are to connect to third parties that Google partner with, such as Jira, ServiceNow, Zendesk, Salesforce. It really is for business purpose. And if you have your thing on schedule, Google got your back, because there's Schedule and Cloud Scheduler. Cloud Pops Up is an enterprise service bus, and if you use Google a lot, that's gonna be one of your things. If nothing of these things fits you, there's always an API event. The rest of the things are tasks, are gonna comprise your workflow, so you're gonna be using them a lot. If you check out this drop-down menu, there's a bunch of artificial intelligence blocks, one of which is language translate. There's numerous ways you can call that Google service, but they have the element right here for you to use straight in the workflow without needing to do anything else, with its own visual form where you can set up input and output parameters and set up authentication scheme. Other tasks available here is their data transformation options, such as data mapping, for instance, which is their no-code, low-code tool where you can basically map object fields one onto another. They have a few scripting capabilities, including JavaScript, where you can write custom code. You can call an external REST endpoint with authentication. You can use a Google Cloud function, which is Google's serverless offering, easy to deploy and use. You can use some of the business elements to suspend your workflow until certain action. And there's some flow control elements for working with loops. A connector is another type of task that allows you to connect to Google services or third-party application and interact with them in a certain way. They also have a bunch of examples available on their website, and it's all backed up by a public repository containing code for those examples. And even though what you're working with is a visual builder, it all translates into code, and as such, you can import and export projects back and forth and build amazing GitHub pipelines around it. Their pricing is based on the pay-as-you-go model, which is different from what we saw about other workflow providers. Here, you're getting some free tier, which is good, but after meeting certain threshold, you're going to be charged for executions, connections, data, and network usage. Google Cloud Workflows is another service with a focus on internal automation rather than business aspects, though it can be used along with the application integration service so that you can get the best of both worlds. They provide with a few use cases here, majorly for application integration and microservice orchestration. You can also use it for data pipelines and process automation, though there are better tools for that out there. Alright, let's have a look what it represents in the console, and we'll dive into some technical details when it's needed. Here I've got a very simple workflow that just does a Wikipedia search and returns some items. On the right side I've got a visual chart of this logic, but as opposed to application integration here, I can't move the elements around. Pretty much everything needs to be defined in code, which is basically a programming language but expressed in a YAML format. They have variables and support of various data types such as strings and lists and maps. They have flow control elements, support for iterations. You can execute actions in parallel. You can invoke other workflows as well. And with connectors, you can virtually run any Google API command, and a standard library that supports various useful functions that you might want to use from time to time. In order to trigger this thing, you have a few options. You can do it in the Cloud Console to test things out. You can use a Google Cloud CLI suite and run it in your terminal. You can use a client library and trigger it from code. You can associate with a Cloud Scheduler and put it on the schedule. You can also associate it with a PubSub, and there is a fancy service called Cloud Tasks that will take care of queuing and buffering for you. There is going to be a free tier as usual, but even when you've exhausted your free tier, you're going to be given a recoverable capacity on a monthly basis. You're only then eventually going to be charged either 1 cent or 2.5 cents per 1,000 steps, depending whether a step involves an external service or an internal one. So now let's get into the step functions, because that is really something interesting and something special AWS has to provide. With step functions, you can build various types of workflows. Standard ones that can last up to a year, and express ones that can handle super intense, highly distributed operations very fast. It covers a variety of scenarios, starting with business process automation with high-level efficiency, processing and events in near real time, all the way down to data and machine learning pipelines, with an ability to process the job in parallel and to large scale. It supports a variety of control flow patterns. You can do a regular function orchestration where functions are processed one after another sequentially. You can do the branching, you can do error handling. With a dedicated function processing your errors, you can put a human in the loop to review and confirm certain operations. You can do parallel processing, you can do dynamic parallels with all of the parallel events converging into a single function at the end. But I don't want to get you bored. Let's actually go ahead and explore the console. So after we hit this create button, it provides us with a bunch of templates. They based on the use case, whether it's data processing, IT automation, machine learning, e-commerce, or based on the service that you know you're going to be using in your workflow. I actually found one interesting case for distributed file processing. Let's choose it and see what it gives us. Wow, this is quite a chart, guys. Let me help you understand what's happening here. First, we're having a look into the bucket to see if there are any objects. If we don't find any objects, we're gonna follow this right branch to copy objects from somewhere else. And we're gonna be doing it in a distributed manner, okay? So this copy object call is going to be run in parallel with 100 items per batch with a concurrency parameter of 1000, okay? Another part of a chart perfectly demonstrates the MapReduce pattern. But first, let me show you what's in the objects for it to make sense, all right? Every single object is represented by a CSV file containing information coming from a weather station. There are multiple records per file. It has the data about station ID, the date when the measurement was taken, the coordinates, temperature, and other things, okay? So this Lambda function processes those files in batches, 500 items at once, large concurrency limit. But we're never going to max it out because the number of items is just 12,000, still large. We only need to invoke this Lambda 24 times in parallel and we're gonna be done, okay? So Lambda basically converts those CSV records into JSON records, and this block then takes care of consolidating all of those responses coming from Lambdas into a single JSON file. Reducer also analyzes the file, takes all the records related to a certain month of the year, finds the highest number, and stores the result in the distributed dynamic DB table, okay? The final result stored in the distributed database is going to look like this. I bet you're gonna be nicely surprised, guys, when it comes to the pricing, because to be honest with you, it's not gonna cost much. Well, apart from a free tier you're gonna be given anyway, which actually includes 4,000 state transitions, you're gonna be charged very little per state transition thereafter, alright? So let's say you have a workflow consisting of 4 state transitions, right? Every state transition, for you to understand, is just a logic flowing from one element to another. So that workflow you'd have to execute 4,000 times for them to charge you for 1 cent. And that for the standard pricing, guys. And remember that one could last up to a year for a very long time. And also keep in mind that it doesn't include the services you're going to be using with your workflow, such as Lambda functions, dynamic DB tables, and all that. But you're going to have to pay for them anyway. So you can essentially define the architecture of your application by connecting the cards together and specifying some properties on them. And in the end, you're going to be given a CloudFormation template generated and ready to be deployed. For those who don't know, CloudFormation is used to define your entire AWS cloud infrastructure in code for repetitive deployment. Let's explore a visual builder now. I've chosen a simple demo that falls out of the bucket of a standard serverless application design and added a few things to it to explore some more capabilities. Another thing to note is that all of these connections here essentially represent the data flow. In this case, we've got an API gateway where stuff is coming in. Whenever an item arrives, it triggers the Lambda function to process it. After processing, the Lambda puts an item into the topic where a few other functions pick it up for reporting purposes. And also everything gets fed into the queue for accumulation. And then there's another function that consumes the queue, processes the items, and puts them into the data store. As a result, you're going to get this template file generated that will allow you to deploy the entire solution in AWS Cloud. But it's not all. You're also going to have to write code for those functions we saw in the chart and organize them in the repository so that CloudFormation picks it up at the deploy time. Remember the distributed processing workflow we put together in the studio. So I'm practically it right here. So it's a part of an application now. It can get triggered by a schedule on demand. There is an additional method on the API gateway that's going to trigger that. And I also added this report method that's going to give you the latest result that's stored in the table. The next thing we're going to be doing is Azure Logic Apps, which is a pretty solid offer by Azure that integrates with many things, spans across the cloud boundaries, provides you with low-code, no-code experience, and most importantly, has a visual designer. I also want to raise another point of comparing these with Microsoft Power Automate, because this is like another thing you can use to build out your workflows, but it's a little bit more like business oriented, though it's fully compatible with underlying technologies because it's built on top of Logic Apps. And as such, you're probably going to see the same triggers and connectors, but with less capabilities to customize certain things and establish an enterprise-ready setup. But then the question is, why would you want to use Azure Logic Apps at all? So if you highly leverage Azure services or planning to, then the choice is probably going to be Logic Apps, because it allows you for a seamless integration with your services, as well as advanced customization options that might be necessary to productionalize your setup. So what is a connector? What kind of connectors are available? These are important concepts to know in an effort of setting this up. With a connector, you can perform an external action in the underlying system, service, or platform, or trigger your workflow in the response of a certain event there. There is so-called built-in version and managed version, where this built-in version is available natively without needing to keep in mind that it's hosted somewhere and you're paying money for it. While a managed connector is likely to be your second choice, sometimes you're gonna have to use it anyway, just for the sake of certain integration options available for it, or simply due to the lack of built-in version available in the first place. One of the really cool features, folks, is the ability to create your own custom connector, so that not only you can reuse it across your workflows, but also share it with other Azure customers who may even pay you for usage. While this may involve some coding, don't worry, Microsoft has your back by providing comprehensive documentation on the topic how to tackle that. Alright, let's get to the console and build something cool. I spent a couple of hours here playing around with things, trying different connectors and triggers, faced quite a few limitations, but finally managed to put something functional together that I'm happy to share with you guys. This is a very simple workflow, but it does something meaningful and also holds an AI part to it. The first element here is the trigger, which I use HTTP request for. You can think of it as a regular webhook, but with the Azure authentication. So you're gonna have to send a specially structured HTTP request to reach this endpoint and trigger your workflow. It also supports this JSON schema, which is gonna allow you to pass over structured data and parse it out into objects or variables for usage in the downstream actions. The next element here I was a little bit struggling with because I was looking for something else but didn't find it, so had to use whatever it offered. This very one is Bing Search supported by Microsoft, and what I was looking for was Google Search supported by an independent vendor, and I wasn't able to use it because of an outdated implementation. But anyway, what I'm doing here is I'm searching for financial news, and Bing, to be honest, can do the job as any other search engine, and it returns multiple results in a JSON document. And then I join the results into a single object and pass it over for an OpenAPI chat completion to extract the news headlines and format them into a bullet list. That is actually something that LLMs excel at. And for you to understand, this is something I'm getting after Bing Search a lot of structured information with news details. And the result after LLM processes it is gonna look like this. And if you run this thing in the console, it's gonna give you this execution flow where you can look up inputs and outputs of particular elements for the ease of troubleshooting. To cover a little bit of pricing, what I did is called consumption plan, and it really doesn't cost much, very comparable to the Express alternative in AWS. But don't forget, you're also gonna have to pay for the connectors. And there is also a standard plan that supports all those fancy features like local development, complex workflows, and custom connectors that turn out aren't quite available in the consumption plan. And for those reasons, this one is obviously much costlier. Alright folks, the last topic on our agenda is Azure AI Studio, but that's quite hell of a topic, that's why I'm not gonna go into all of it. After playing with it for a couple of hours, I realized they've built a lot of goodies. This Azure AI Studio is their latest addition to already a comprehensive set of machine learning tools and AI services. But this very one provides you with a good playground to experiment with models' capabilities in the most efficient way. And it does that by empowering you with a bunch of features like managed model deployment, custom data sources along with retrieval methods, evaluation framework, fine-tuning, and my favorite of all, the prompt flow. And that is, guys, who we're going to be focusing today. And I'll leave the rest for another video because it goes along very much so with other workflow tools we've just discussed. Prompt flow is a tool that allows you to build pipelines of operations to process your inputs into the outputs in multiple steps using various tools. Those can be OpenAI GPT models and open source models as well, like Llama and Mixtral, which you can choose in Model Garden and deploy following a managed process, but also the tools for Google Search, for instance, with SERP, similarity search in vector databases, regular coding with Python, and there's a special prompt tool that would allow you to experiment with various prompts against different models. If you look into the prompt flow section of an AI Studio, it's gonna suggest you a couple of templates to start with. I've chosen a simple one to answer a user question with information retrieval from Wikipedia. As you can see here, it consists of a couple of steps, starting with search on Wiki and then following the links found to extract main content from the pages, and then passing it over into the prompt with a question answering task for a model, providing the context extracted. And that is basically how it works, but in order to execute it, you gotta choose the runtime that is going to initiate the installation of all of the dependencies in your execution environment, which could take a couple of minutes, but don't worry, you only need to do that once. Also, don't forget that you have to associate every prompt step with a specific model for execution. Can be, again, OpenAI model or open source model that you deployed in the studio. And once you've done all of this, you hit this little blue run button in the corner, and that will do the trick. You might be interested why I have all these red failed signs all over. Well, in order to have an OpenAI model do the work for you in the flow, you gotta apply for it first. And in this internal application, you gotta specify the reasoning, and it's gonna take them up to a couple of days to review it and approve it. And as you can tell, it's still in the works. But I also tried this alternative way while waiting for my application to be approved. I actually went ahead and deployed this open source model Llama using the smallest possible instance, which still cost me about like $10 an hour, crazy. And as you can see, it didn't quite go the way I wanted. And I didn't have much time to look further into it. So anyway, the tool is good, provided you've got your application approved and you can actually make use of a normal model, but it just gives you a few more managed capabilities to streamline your development effort. So finally, we've reviewed all of the offerings, and there is no single winner, I think. Some tools better than others at something, And it's really gonna depend on how much familiar you are with particular cloud already, or perhaps if you're already using it for something. But my personal take is that AWS Step Functions is a really good choice, especially given that how much effort they're putting into optimizing their runtime environment. Every time there is a new announcement about a performance improvement or a new feature or integration. But I wouldn't consider this the only option because other clouds definitely have something to offer too. And on this positive note, I would like to thank you all for watching. I hope you've learned something from it. Reach out to me in the comments or through social media. I'd be so much happy to engage. Hit this like button because there's more great content coming, and stay tuned. I'll see you soon.